negative exponents. So negative exponents occur when, if you have something like x to the negative a. Okay. When you see something like this, it means that you should instead put it into the denominator. So you have 1 over x to the a. That's all negative exponents do. So if we have 2 to the negative second power, I see this and immediately I say, okay, negative exponent, I don't know how to evaluate that. What it means is I put it into the denominator and I flip the sign to positive, right? So we had x to the negative a, then we had 1 over x to the positive a. Here we have 2 to the negative 2, so I'm going to write this as 1 over 2 to the positive 2. And once it's in this form, then we can evaluate it like we would at any other exponent. So I know 2 squared is 4, so it's going to turn into 1/4. Okay. You can do the same thing if you have something like this in the denominator. So if I had 1 over, let's say 3 to the negative 2. Well, here you might say, uh-oh, I have a negative exponent. I know when I have negative exponents, I'm supposed to put it in the denominator, but this is already the denominator and it's still negative. What do I do here? You always flip it, right? So up here, it's up top, and you put it in the denominator. Down here, you have something in the denominator, so you are able to instead flip this into the numerator. So the 3 to the negative 2 just goes up and turns into 3 to the positive 2, which is just 9. Okay. So let's try. You can pause the video in a moment here. Let's say I have 1 over 4 to the negative 2, and let's say I have 10 to the negative 1. So go ahead and pause, try to do those, see if you can get the right answer. So this should end up being, here we have 4 to the negative 2 in the denominator, so I move it into the numerator. So this turns into 4 squared, which is 16. And over here, 10 to the negative 1, negative exponent means we put it in the denominator, so this turns into 1 over 10 to the positive 1. So this is just going to be 1/10. Okay. What happens if you already have something in the numerator? What if I have, instead of 1 over 4 to the negative 2, what if I had 2 over 4 to the negative 2? You do everything the same, but you're only moving around the stuff that has the negative exponent. So if I have a 2 in the numerator, what happens is I write, okay, I have a 2 in the numerator, and then for the negative 2, we're moving that into the numerator and we're flipping the sign to positive. So this turns into 2 times 4 squared. So this gives me 2 times 16, which is 32. Okay. You do the same thing if I had 10 to the negative 1 over 7. I would say, okay, I have a negative exponent here. So it's going to be 1 over 7 is in the denominator. 7 has no negative exponent, right? I'm going to leave it where it is. I'm not going to do anything to that. But the 10 to the negative 1 is a negative exponent and is in the numerator. So I need to bring that down to the denominator. So I have 7 over 10 to the 1. So then I can evaluate this normally. 10 to the 1 is 10. 7 times 10 is 70. And my answer is 1 over 70. Okay. So with this tool, we can move on to some problems that involve combining multiple rules, right? So I could say, suppose I have x squared times y divided by y cubed squared. So here, and there's no negative exponents up front, but there might be a negative exponent as we kind of work through this problem. So the first thing I like to do, you really have two options. There's no wrong way to do these problems, unless you, I guess, do something that is wrong. But you can kind of approach it however you'd like. So we can start out by simplifying what's inside the parentheses, or you can start by distributing the 2 into everything inside here. Personally, I like simplifying inside the parentheses first because I like, the sooner you simplify stuff, the fewer calculations you're going to have to do and the fewer opportunities for mistakes you have. So I'm going to simplify what's in here, and this turns into x squared. There's no x on the bottom, so I just keep the x squared on top. But here I have y, and I have a y cubed on the bottom. So I know that if I have something that shares a common base, and there's an invisible 1 here, right? And they're being divided, I subtract the powers. So this means I have y to the power of 1 minus 3. 1 minus 3 is negative 2. Okay. So again, you can either simplify a little bit in here, or you can distribute the 2. Either one's going to be fine. If I simplify in here first, I'm going to rewrite this, since I have a negative exponent, as x squared divided by y squared. and that's still going to be raised to the second power. Now there's nothing I can really do in here. Okay, I can't simplify this anymore. These do not share common bases. I can't multiply, divide, subtract, anything like that. So I distribute the 2 in. Remember, whenever you have an exponent raised to an exponent, you multiply them. And if you have multiple things in here, it hits everything in here. So this is going to turn into x to the 2 times 2 is 4, divided by y to the 2 times 2 is 4. And that's it. That's your answer. Okay. Real quick, and you can skip ahead if you'd like, I'll show you that you can really do this in any order and it will still work. We could distribute the 2 first, and we get 2 times 2 is 4, y 1 times 2 is 2, 3 times 2 is 6, so I have y to the 6th. And then I can simplify in here, so I have x to the 4th, y to the 2 minus 6 is negative 4, and then this turns into x to the 4th over y to the 4th, right? So it works the same if you distribute first. You can really do anything. Okay, let's try one more. Let's say I have x to the negative 2, y to the 3, divided by z to the negative 1, and I'll say the whole thing is squared. So again, you have options. You can distribute the 2, or you can simplify what's inside the parentheses first. And again, I prefer to simplify first, so I'm just going to do some rearranging in here. So I see I have an x to the negative 2 in the numerator. That needs to go to the denominator. The z to the negative 1 in the denominator, that needs to move to the numerator. And the y cubed stays where it is because it has a positive exponent. So this is going to turn into y cubed times z, z to the 1 power, right, which is just z, divided by x squared. And this whole thing is going to be raised to the second power. And then from here, nothing else I can do. There's no common basis for me to work with, so I can distribute the 2 and raise each of the terms in here to the second power. So this is going to turn into y to the 3 times 2 is 6. Remember, you multiply when you have an exponent raised to an exponent, times z, 1 times 2 is 2, divided by x, 2 times 2 is 4. So x to the 4th. And that would be our answer for that one. Okay. So that's how you work with negative exponents. It can take a little bit getting used to, especially when you have them kind of in the denominator. But the key to just remember is, like, wherever it is, you need to make it positive by putting it into the denominator if it's in the numerator, or the numerator if it's in the denominator. So next time we're going to be talking about another kind of exponent. We're going to be talking about roots, which can also be represented as exponents.